Hello, grade 10s. We're going on to applications of the gradient. Just remember, everything that's over here you need to take down into your books, okay? Also, what I've done is I've just printed 2 slides per page. It just makes it easier, okay? So we've got a few things here to discuss first. The first point here is collinear points, points that lie in the same straight line. So all this means is if I had to draw a straight line, that just means some point A, B, and C all lie on that same straight line. Okay, so A, B, and C are collinear points if the 2 line segments joining at B are equal gradients. Now, don't worry about that. I will go through an example over here and show you. Okay, there's just a couple of things here that I want you to highlight. Now, if lines are parallel, that means that their gradients will be equal. If lines are perpendicular, that means that their product of their gradients is equal to -1. And again, guys, don't worry too much about it now. I'll go through an example and show you, but I just need you to get that done. Okay, so if we look at example 2, it says here, show that the following points are collinear, P, Q, and R. Now, when you're trying to show something is collinear, you're always going to choose an anchor point, okay? And I'm just going to choose P as my anchor point. Now, what that means by an anchor point is I'm going to find the gradient of PQ, and then I will find the gradient of PR. Okay, and as you can see, P is in both of them, and that's what I mean by an anchor point. It's just common with both of them. Okay, so if we work out the gradient of PQ, remember it's y2 minus y1 over x2 minus x1. So this is our second point here. So it's going to be 4 minus 10 over minus 1 minus 1. And we can just plug that in the calculator and get the gradient. So we have here 4 minus 10 over minus 1 minus 1. And we get a gradient of 3. So that is the gradient of PQ. Now I'm going to do the same thing for PR. So it's y2 minus y1 over x2 minus x1. So this is our second point now. So we get here minus 2 minus 10 over minus 3 minus 1. And plug that on the calculator to work out the gradient. And we get minus 2 minus 10 over minus 3 minus 1. And we get 3. Now, what I want you to notice here is both of these gradients, PQ is equal to 3 and PR is equal to 3. Now, because they have the same gradients, therefore, P, Q, and R are collinear. In other words, they lie on the same straight line. Because it doesn't make a difference which point I choose on the straight line, it will have the same gradient if it is on that line. For example, if B, and this is just, I'm going to do it in another color, if say if B was over here, and I chose my anchor point to be A, you can see that the gradient of AB will be different from the gradient AC. Therefore, they can't be collinear. Okay, so they must have the same gradients to be collinear. All right, going on to example 3. Now, guys, don't get worried about the examples. Example 1 was from the previous lesson. Okay, so example 3. Calculate the gradients of AB and CD, and hence determine whether the line segments AB and CD are parallel, perpendicular, or neither. And we've got 2 different questions here. So question A. Now, Remember over here, if lines are parallel, they have the same gradient. If lines are perpendicular, the product of their gradients is -1. And that's what we're going to be using. So first of all, what I'm going to do is I'm going to find the gradient of AB. So that is y2 minus y1 over x2 minus x1. And we get 3 minus 5 over minus 3 minus 1. Minus 3 minus minus 1. Okay, so 3 minus 5 over minus 3 minus minus 1. And we get a gradient of 1. Okay, so now I'm going to work out the gradient of CD. y2 minus y1 over x2 minus x1. Okay, so second point here is -1 minus 8 over -5 minus 4. And we get a gradient for CD to be -1 minus 8 over -5 minus 4. And we get 1. Okay, so if we look at these two gradients now, we've got the gradient of AB is equal to 1 and the gradient of CD is equal to 1. Now, because the gradients are equal, that means that the lines are parallel. Okay, so therefore, AB parallel CD. Okay, just because the gradients are equal. Let's look at example B now. Again, working out the gradients of AB and then CD. So the gradient of AB will be equal to y2 minus y1 over x2 minus x1. So we've got here 5 minus 1 over minus 3 minus 1. And we get a gradient of AB is equal to -2. Okay, let's find out the gradient of CD. y2 minus y1 over x2 minus x1. So this is our second point. So we get 4 minus 5 over minus 5 minus 3. And we get a gradient of CD is equal to 4 minus 5 over minus 5 minus 3. And we get a half. Okay, so as we can see here, that the gradient of AB is -2, the gradient of CD is a half. These are not equal, therefore they are not parallel, but they could be perpendicular. So what I'm going to do here is I'm just going to take the gradient of AB and multiply it with the gradient of CD. And if I get an answer of -1, then they are perpendicular. So we get here -2, because that's the gradient of AB, multiplied by the gradient of CD, which is a half. And this you can just calculate, guys. -2 times a half is -1. Now, because this is equal to -1, therefore AB is perpendicular to CD. Okay, let's have a look at another case. So if this gradient was not equal to that gradient, then they're not parallel. So for example, like this, they're not parallel. But then we must just test, is the product equal to -1? If the product is not equal to -1, some other random number, then they're not perpendicular. So they won't be parallel and they won't be perpendicular. Okay, guys. So for homework, what you can do is 11.4, number 3, ABC, number 4, and number 5 for me, please. Thank you.